So far, we've learnt a few things about light. So let's go over some of the basics again. We know that light is a type of energy. And we know that we can see it. So we can see light. And we've learnt before that light is made up of different colours. But this video, we're going to challenge some of these basic ideas, and we need to change our thinking to make things a little bit more complicated. So let's look at this diagram down here, and we can see the colours of the rainbow are actually just in this middle section here. And what scientists discovered is that this section here, this is the only part of light that we can see, and we call it visible light. But actually, they discovered that there's a whole lot more types of light or types of radiation that we can't see as humans. And this was a really important idea that scientists discovered, which is that visible light is only a small part of this wider spectrum. And they called this spectrum the electromagnetic spectrum. Visible light is only a small part of the electromagnetic spectrum. So instead of just calling it light, we now want to expand our thinking and call it electromagnetic radiation. Electromagnetic radiation. So light is still a part of it, but normally light just refers to the part that we can see, so visible light. And for the rest of this video, we're going to look at all the other types of electromagnetic radiation, because you would have actually heard of a lot of them. So we'll start by looking at the longer wavelength side. We can see that red, we remember that red is the colour with the longest wavelength. And we'll look on the left here at these other types of radiation. So right next to red, we have something called infrared radiation. Or in other words, IR. And you might have heard of IR before. Infrared radiation is really just heat. So we can't feel it, but any object that's hot, we can feel that radiation coming off the hot object, and we detect it with our skin and think of it as heat. But we've also invented things like night vision goggles, and these detect infrared radiation. They can look at animals and see their heat, which helps us to see in the dark. A little bit further along on our spectrum, to have even longer wavelengths, these are microwaves. And obviously we know what microwaves can be used for. Pretty much everybody has a microwave in their house. So this type of radiation, it causes water to heat up. And we discovered that if we put foods and we send lots of microwaves in there, then that causes the food to heat up, because foods have a lot of water in them. And that's how we invented microwaves. Then going to an even longer wavelength, right down at the end, we have radio waves. So these have the longest wavelength that we know of. And radio waves are also really useful because, and we can see on our diagram here, this is how we send messages through the air to detect radios and to send to our TVs and to make phone calls. So we use this type of radiation for sending information. So televisions, phones, and radios, of course. A really important type of radiation. Now we'll look on the other side of the spectrum. So this side has shorter wavelengths. And what we've discovered is that shorter wavelengths, they have higher energy as well, which is important when we're looking at these types of radiation, because these have so much energy that they can be dangerous to humans. So the first one that's near the violet, this is called ultraviolet radiation. Or we know it as UV light, UV radiation. And UV light, it can be useful, but it can also be dangerous too. So in these pictures, we can see that UV light, which we also sometimes call black lights, it can cause things to be fluorescent, which is great if you want to make some decorations for parties and things. Or you can have fluorescent pens that write with secret ink, and you need a UV light to show them up. But the problem with UV light is it can also be dangerous too. And living in Australia, we all know the dangers of getting burnt. UV light can cause sunburns and lead to skin cancer as well. Next along in our spectrum, this one here, we have X-rays. So going back, this whole region here is UV light, and it's the high energy part here which is dangerous. Black lights are the low energy here. So X-rays, going back here, we know how useful X-rays can be because they can go through skin. And that helps us to see inside someone's body. And there are lots of important uses for X-rays. X-ray machines in medicine. Lastly though, all the way down at the end, with a really short wavelength, we have gamma rays, or gamma radiation. And these are the highest energy types of radiation, which means they are extremely dangerous. And gamma radiation is released, it's released in space from stars, and supernovas when stars explode, but gamma rays are also released by nuclear bombs. Nuclear explosions. And this is part of the reason why nuclear weapons are so dangerous, because gamma radiation causes it basically poisons humans. It causes radiation sickness, and depending on how much of the radiation you get exposed to, it can kill you within minutes. It's also released by just radioactive materials in general. Which is why at nuclear power plants, it's really important that people wear protective clothing so they're not exposed to any of the gamma radiation.